So now I'm thinking of a 4-digit binary number.
Oh, binary.
Binary. Okay.
Okay, 1 0 0 0.
Low.
1 1 0 0.
Low.
1 1 1 0.
You're too high.
1 1 0 1.
Yes!
Yay! In the game we just played, we used sequential logic to make our guesses, or outputs. Now, sequential logic is a type of logic in which the outputs depend not only on the current inputs, but also on the value of past inputs.
Like in the game we just played, our guesses or our outputs would change depending on whether our previous guess was too high or too low.
We used that information, remembered it, and used it to make our next guess. One of the things we use sequential logic for is with flip-flops.
This flip-flop?
No, silly. This kind of flip-flop.
One of the most basic data storage circuits are SR flip-flops. There are two main types of SR flip-flops: a cross-NOR SR flip-flop and the cross-NAND SR flip-flop.
Let's take a look at the cross-NOR flip-flop first. We have two inputs, S and R, which stand for set and reset, and two outputs, Q and Q bar. When S is 1 and R is 0, Q is 1 and Q bar is 0. We have a set condition. When the values are flipped and S is 0 and R is 1, Q is 0 and Q bar is 1, and we have a reset condition. We know that NOR gates will output a high or a 1 if both inputs are low or 0. So then we know when S and R are high, we'll produce a low output for Q and Q bar.
1.
However, we can't predict values for Q and Q bar to be 1 when S and R are both 0. Why? Because, as we said before, these circuits use sequential logic, which depends on previous outputs. If there are no outputs, we cannot apply our logic.
NAND gates are very similar, except that everything is flipped, because NAND gates are basically the opposite of NOR gates. They will output a low only when both inputs are high. Sequential logic is important in these flip-flop devices, but in general they're important for memory storage. This is useful in all types of electronics, but also in particularly computers.
Through the loop. So,
that's it for sequential logic.
We hope you remember everything we taught you, and we'll calculate later.